Example 5 wants us to find the following limits if they exist. Part A wants us to find the limit as x approaches 1 of 2x cubed minus 7x. Now, this is an example of a polynomial, so based off the properties that we saw previously, we can just plug in and substitute 1 to calculate our limit. So it's going to equal 2 times 1 cubed minus 7 times 1, which is 2 minus 7, which equals negative 5. So our limit there is equal to negative 5. Let's look at part B. Part B wants us to evaluate the limit as x approaches 3 of the quantity x squared minus 2 divided by the quantity x plus 8. Now, remember for rational functions, we can plug in the x value as long as it doesn't make the denominator 0, which in this case it does not. So we can go ahead and just plug in 3 squared minus 2 over 3 plus 8. So that gives us 9 minus 2 over 11, and so our final answer is 7 over 11. Okay, part C wants us to find the limit as x approaches 2 of 2x all over x squared minus 4. Now this is an example of a rational function where if we plugged in 2, it would make the denominator 0. So I'm going to do that off to the side here. Notice that if I plugged in 2 times 0, that was supposed to be a 2. If I do 2 times 2 over 2 squared minus 4, that ends up being 4 over 4 minus 4, which is 0. So we have to think about a different strategy. We can't just plug in x equals 2 in this example. So the next thing that you want to do for rational functions is you want to try and see if it's factorable, which in this case it's not. So we could do 2x over x plus 2 over x minus 2. I take that back, sorry. It is factorable, but we can't cancel out or divide out any terms from both the numerator and the denominator. So I factored it here, but that doesn't get us anywhere. So the next thing is we are going to graph it. And so I'm going to make an XY table, and we're going to approach values from both the left side of 2 and the right side. So I might do 1.9, 1.99, 1.999, maybe 2.001, 2.01, and 2.1 to see if that might help us figure out some of those values. Now I'm going to go ahead and do that, and I'm going to ask that you do that on a calculator on your own, and then I'll come back with those values. All right, so these are the values that I came back with, and notice that if you approach 2 from the left-hand side, if you plug in 1.9, 1.99, 1.999, the values are getting very, very negative. So basically the y values are going towards negative infinity, whereas if you evaluate values from the left-hand side, or sorry, the right-hand side approaching 2, they're getting larger and larger. They're going from 10.2 to 100.2 to 1000.2. So what that's going to look like is, let's say here's my x-axis, here's my y-axis, here's 2. If I plugged in 2, hopefully you remember from pre-calculus that there's a vertical asymptote there. And what's going to happen is our function graph, if we come in from the left-hand side, is going to go down to negative infinity, and then the right-hand side, it's going to go to positive infinity. So because they're not going towards the same thing, we know that this limit does not exist. So that is what we were looking for in part C. Let's move on to part D. We want to find the limit as x approaches 2 of 3x squared minus 7x plus 2 all over 2 minus x. Now, this is a rational function example. If we plugged in 2, it would make the denominator 0 because 2 minus 2 is 0. So we need to move on to our next tactic, which would be factoring. So the numerator is a quadratic function, and we want to try to see if that's factorable. So this is the way that I learned how to factor quadratic functions if the leading coefficient is not a 1. So here you'd put a -7, and then in the bottom you would multiply the a value and the c value. So 3 times 2 is 6. And you want to find two numbers that add to -7 and multiply to +6. And the two numbers that do this for us are -6 and -1. So what we want to do is we want to rewrite 3x squared, and we want to break the middle term into -6 and -x plus 2. Now notice that if we combine like terms, it would give us the original numerator. And now what we can do is we can factor out any common stuff from the the first two terms and the second two terms. So in the first two terms, I could factor out a 3x, and that would leave me with x minus 2. And in the second two terms, I could factor out a -1, and that would leave me with x minus 2. Now, both of these terms now have an x minus 2, and I can factor that out. So there's an x minus 2 here and an x minus 2 here. If I factored those both out, I'd get x minus 2, and then what's left over is 3x minus 1. So if we rewrote our limit, it would look like the limit as x approaches 2 of the function x minus 2 times 3x minus 1 all over 2 minus x. However, notice that here we have an x minus 2, and if we factored out a -1 from the denominator, then we could rearrange it and get x minus 2. And then from there, these x minus 2's can divide out. And so now that's going to equal the limit as x approaches 2 of 3x minus 1 over -1. Now we can just plug in 2 because it's not going to make the denominator 0. So this is going to equal 3 times 2 minus 1 divided by -1. And that's going to equal 6 minus 1 divided by -1. And 6 minus 1 is 5, so our final answer should be -5.